In this video, I'll talk about a rotating fan. We are given a fan which is rotating with a constant angular acceleration. When it says constant angular acceleration, that means it is speeding up and the rate is given. It is just like a linear acceleration if you are in linear motion. So now we need to find out what is the angular, or if the given thing is if the angular speed of the fan is 4 radian per second at time t equals to 0, then we need to find out the angular speed at a later time, which is time t equals to 10 seconds. And we also need to find out the angular displacement. When it says angular displacement, then it is asking you to calculate theta and the number of revolution made in time t equals to 10 seconds. So let's do it. So the given quantity or the given values are alpha, which is the angular acceleration. Remember, this is just like a linear acceleration in linear dynamics. And omega naught, the omega naught is the initial angular speed, which is 4 radian per second. And now we have to find out the angular speed at a later time, or at time t equals to 10 seconds. Then we know that this is relation here. Omega, which is the angular speed at some other time, and omega naught, which is the angular speed at time t equals to 0, or the starting time, or the initial angular speed. Alpha is again the angular acceleration, t is the time. And this relation is exactly identical to the relation v equals to u plus at, which is you might have studied in linear dynamics or one-dimensional motion. Okay, so if you remember this relation, you can write down exactly the identical relation in rotational dynamics. The only thing you have to do is the v, you have to change the angular speed, and this initial speed you have to change it to the initial angular speed. A here is the acceleration, you have to change it to linear acceleration, and the time is the time. So now let's just plug in all the values. So we need to find out omega naught, which is given as the initial angular speed, which is 4. Always keep the unit of omega naught to radian per second. The alpha is given, which is 5, and we have to find out at the time t equals to 10 seconds. That means the angular speed is 54 radian per second. Now we need to find out the angular displacement. The angular displacement is just like the linear distance traveled in linear dynamics or linear motion. So if you have studied this relation S equals to ut plus half at squared, then you should be able to write the corresponding relation in rotational dynamics. In this case, in rotational dynamics, the S is the angle, because it is now revolving about its axis. So the only thing that is moving or changing is the angle here. And theta naught is the initial angular position, and u is the omega naught, again t is the time, half a is again replaced by the alpha. So this is now our relation in rotational dynamics for calculating the angular displacement. We need to find out theta, and theta naught, as I mentioned earlier, is the initial angular position. So this is 0. That means at time t equals to 0, we assume this is the starting point. That is the starting point. And omega naught, we already know it is 4. And we need to find out the time, which is 10 seconds. Half alpha is the angular acceleration. That means it is speeding up. Just like the moment when you turn the fan on, what happens? It keeps speeding up. and the rate at which the angular speed changes is the alpha, or the angular acceleration, and that is given as 5. And again, t is the time, which is 10 seconds. If you solve it, you get the 290 radian. So this is in radian. Now you need to change it to the degree. So this is in degree. What is asking here? The number of revolutions. That means how many complete turns, or how many turns it has made in this time t equals to 10 seconds. Or this fan, how many turns this blade has turned. How do you find out? So we know that the one revolution is equal to 360 degree, or 2 pi. You can also write down as 2 pi if you feel comfortable that way. And if you need to calculate in degree, the 1 degree is 1 over 360 degree. So this is in degree, and this is 1 over 300 revolution. This would be in revolution. Let me write down here, or simply call REV. That stands for revolution. So now we have this much degree. So if I need to change the degree into revolution, I simply have to divide by 1 over 360. So it's divided by 360, and I get is 46.2 revolution. That means it has turned slightly more than 46 complete turns in time t equals to 10 seconds. So this is about the rotating fan, where we have calculated the angular speed, angular displacement, and the number of revolutions. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share, and subscribe the channel. Thank you very much.